In, in this part 7 of lesson 5, we will create this exercise temperature warnings VI cluster, create clusters, reorder clusters, and use the cluster function to assemble and disassemble elements. This is the objective of this exercise. Refer to participant manual guide. So create a cluster data type containing the data to be passed around an application and in the process to create scalable and readable code. So using clusters, how to create a readable, scalable code, you will learn in this VI. Another developer has created a VI that displays temperature warnings. This VI is part of temperature weather station project studied throughout this course. Your task is to update this VI to use clusters instead of individual terminals of inputs and outputs. This is a scenario and this is a flow chart in figure 5.9 to illustrate how to design this temperature warning VI directory. So we will keep this chart in our mind, flow chart in our mind if this is given. So I hope that you can create your code yourself. So we'll just consider this flow chart in front of our eyes and we'll design this code ourselves and test our lab coding skills. Alright, so for this, kindly go to core 1 exercise weather warning directory and open this weather warning levy project and in it open this temperature warning VI. So you see this is given to you. This code is given to you. Now you have to create the clusters in order to complete this flowchart. Alright. Okay. What I would prefer to do in this exercise is let us do everything from very beginning. Let us create a new VI and design everything ourselves. This will be more fruitful to understand everything and let us design entire project from very beginning. Save this VI named as temperature warning. Our code so that I may remember. Okay, press Control T. Now, see the flow chart tells us that first we compare current temperature with maximum temperature. If current temperature is greater or equal to maximum temperature, then it should give us a warning text showing heat stroke warning. If it is not the case, then warning text should show you no warning. So we want one numeric control where user can enter current temperature. We want one string control where user can mention the warning regarding warning text. If the current temperature is less than or is equal to minimum temperature, then it should warn us that freeze warning. And if it is no, then pass this value, whatever value is coming from here, to this place. So we also need, basically we need now three numeric controls. One showing current temperature, second maximum temperature, third minimum temperature, and we want fourth one is string control showing the warning text in this code. And then if warning text is no warning, if no warning is coming, then warning should be false. And this is LED. LED should not glow if there is no warning. If there is a warning, then LED should glow, showing that warning has occurred. So fifth data type that we want in this flowchart is basically an LED. So let us take these all different data types as per the requirement of the program. We want numeric control, name it current temperature. You also want another numeric control, name it maximum temperature, and another numeric control, name it minimum temperature. Alright, you want one string control to show the warning text, and one LED to show whether the warning is activated or not. So these data types are used in the program. Now let us create a cluster for these all different data types. So go to the array subpalette matrix and cluster, and then place a cluster here. Break this cluster to here. Pick these all components within the cluster. Then select the border. Go to auto sizing. Arrange it vertically. Alright. Okay. So this is the order of the flow of the cluster. Please remember that you can also change the order. Like you can make this warning LED to go up and then this warning text. In order to change the order, right click it, go to reorder. First there should be current temperature, alright, then maximum temperature, alright, then minimum temperature, alright, then we should show this warning LED and then warning text. Click confirm. Now this reorder has happened. Alright, this is the cluster available ready now. Okay, now see the flow of the program. It should test whether the current temperature is greater than or not, is not greater than maximum temperature. So we should pick a function of greater than is equal to and compare the current temperature with maximum temperature. So how to disassemble this cluster in order to uh, check this condition we already studied, we should use unbundle by name function to disassemble the data types coming from the cluster. Alright, connect it here. Okay, so now what do you need? Current temperature and maximum temperature. Now test the condition as per the requirement of the program, that whether it is greater than or not greater than the maximum temperature. So if the current temperature is greater than the maximum temperature, if this is true, then warning text should show heat stroke warning, otherwise it should show no warning. So we have two conditions, either this or this. And if this is a scenario, select terminal will be best for this purpose. So get a select terminal, connect this condition terminal here. So now if it is true, current temperature is greater than maximum temperature, then the above condition will execute. Take a string constant and it should show us that heat stroke warning. Temperature is very high. Heat stroke warning. Because current temperature is greater than the maximum temperature. So it should alert about the heat stroke warning. And if it is not the case, otherwise it should show us basically no warning. You can also rename the cluster. Let's make the cluster name is, let's say, weather data. Alright. Okay, we have completed up to now. And then it tests, is the current temperature less than or is equal to minimum temperature? We want to take this comparison palette and take this less than is equal to and compare current temperature with minimum temperature. So I also disassemble third terminal from here and I go to comparison palette and I select less than or equal to from here, and it should compare current temperature with this minimum temperature. If current temperature is less than or is equal to minimum temperature, then it should show us freeze warning alarm. Otherwise, it should pass the previous value coming from here to here. So, and again copy this select terminal from here. So if current temperature is less than minimum temperature, it should show us freeze warning. Because it is less than minimum, certainly it should show a freeze warning. Alright, if it is not the case, then whatever the warning is coming from here should be transferred at this place. Alright, see, you see, whatever the value is coming from here is passed here, pass current value of warning test to here. And finally, it should test warning text is equal to no warning. If there is no warning, if there is no warning, then warning should be false. So for this purpose, we are going to comparison palette and selecting not equal to. If here from no warning is coming and here is also no warning, if no warning is coming from here and from here there is also no warning, you can see if from both places no warning is coming, then this will be true, otherwise this will be false. Alright, so for this purpose, now we have taken this not function. Alright, and then we need to go to character palette and then we should select bundle by name function to modify our cluster. Now we need to modify our cluster, replace some values. Alright, okay, from here it should be warning LED. Okay, connected here. So I again repeat, if no warning is coming from, if suppose freeze warning is coming from here and no warning is coming from here, then freeze warning is not equal to no warning. This will be true. This will be true. Freeze warning is not equal to no warning, and then LED will glow. Otherwise, if no warning is coming from here and no warning is coming from here, then it will become equal, then it will be false and LED will not glow. So this is the logic. Alright. Finally, you should also show the text. So break this component and whatever the text is coming from here, this will show either the freeze warning or heat stroke warning or no warning at this place connected here. Okay. So you see this code is now complete. It will test if there is any warning. If there is warning, then this LED will glow. If there is no warning, LED will not glow. Alright. And it will also show us the text. And now certainly we want to see this on cluster indicator. Where will you see the output? Certainly on cluster indicator. So copy this weather data and make it weather data out. This is basically weather data in. And change it to indicator. Alright. And then connect this to indicator to see the results. I hope now code is clear. Now let us test this code. If the current temperature is 30, let us say maximum temperature is 50 and minimum temperature is, say, suppose 10. And since in Pakistan maximum temperature goes up to 50 and minimum may go below 10 centigrade as well. Okay, hit the run button. You see there is no warning and the code is running correct. If your current temperature exceeds the maximum temperature 51, there is heat stroke. You see heat stroke warning is activated. And if it is below the 10 centigrade, 5 centigrade, then warning is activated and it shows freeze warning. So the code is working as per our expectation. Thank you for watching this exercise. We completed now exercise 5.1. Let us go to this questions lesson 5, exercise 5.2. What would happen if you reordered cluster elements? So Both the sub VI and calling VI would continue to work as expected since the only cluster functions used are unbundle by name and bundle by name. A change to element order in a cluster, sorry, a change to element order in a cluster does not break these functions. Okay, what would happen if you added a cluster element to weather data out? So if you added any extra cluster element to weather data out, both the sub VI and the calling VI would be broken because of mismatching cluster data types. So if you have created a cluster indicator from a cluster control and you are changing the data type of cluster indicator, then certainly the data type of cluster control if will not match with the cluster indicator, then you will in result get cluster indicator. And how to solve this issue we'll discuss in our coming video. Next topic of our video in part 8 will be type definitions. Thank you.